Good evening, ladies and gentlemen. Today I'll be talking about toilets. I have, in my previous career, have managed pretty large construction projects, airport terminals and constructions, but I'm finding this project one of the most exciting. So I'm going to just take the liberty of sharing some of those ideas with you. I'm sure most of you would know Mr. Gates. Besides one of the richest person on earth at the moment, he's one of the very active philanthropists. I didn't realize that the money that he's putting in the foundation is basically his personal money, and it has nothing to do with the Microsoft Corporation. So the foundation is going on for some time, and I think they have a portfolio of $4 billion at the moment, including lots of vaccine preparation, agriculture, and one of the programs is water sanitation and health hygiene. There are two main components of that. One is basically supporting our conventional water and sanitation with the view to increase the access to safe water and safe sanitation. But they have also come up with another stream of program which try to really shake the whole sector by challenging the experts to come up with new ideas. I think there is a realization that many of these ideas may not work, but there is a reasonable chance that some of those could turn into either individually or in combination game changers in the sector. So that happened on 14th of August this year, when after our first phase, we were asked to go and present our prototype in Seattle in front of the panels. And I was given, in the end, 5 to 6 minutes, and I was constrained to do 3 slides in front of Mr. Gates. And after that, we were given the second prize on our concept. We were beaten by Caltech, but we sort of were ahead of Stanford and some other universities.
We noticed.
So basically, if you look at these pictures, what we have proposed is to convert just these. This is basically fecal sludge, or basically shit, which is very hazardous and harmful. And through the process, we are trying to convert that into valuable material safe to touch. And these are the real pictures, and I forgot to bring some samples because it smells like coffee. Apologies to coffee lovers or caramel, and you can feel the granules of that. So basically, what we are trying to do is to, before I go on that, let me give the bigger picture. 3.2 billion people at the moment don't have toilets. The people who have toilets, you don't really know where the excreta is going, whether it's treated or not. Even in Europe, there are cities where human excreta is more or less dumped straight into fresh waters, and there's a whole implication of that. So it is not just the developing countries' issue. And if you think about health cost and things, diarrhea, there's thousands of children are dying every minute as we speak because of lack of toilets. So basically, we want to have toilet which basically is desirable. So if you go to many countries, you don't want to use loo because they are so dirty, they're smelly, and it's very hard to go in. So I think in our team, we have people from design school, from chemical engineering, from civil engineering, and from materials working together to create a desirable space in toilet so that you can also treat your toilets respectfully. Now, why we are doing that? Because I think studies have shown, World Bank, I think, that we have the least willingness to pay for our toilets or sanitation as compared to highest willingness to pay, let's say, for power and telecommunication. And that creates lots of problem for developing any business case for investment. We think, along with just treating the normal fecal sludge, we will be exploring whether menstrual hygiene waste could also be treated, because that is one of the things which we don't talk about, but there are many countries where there's a huge loss of students when they reach to that stage because you don't have toilets to deal with that menstrual hygiene waste. So we are thinking about whether some of the technologies we are going to develop could also treat organic aspects of that waste. Then we have a market, besides the developing countries, even in states and here, where you don't really have piped or network connections. You have big gatherings. I was told that this year, Glastonbury festival was postponed, and one of the reasons was that they didn't have the toilets because all toilets were moved to Olympic. I don't know, but there are lots of big gatherings where you do need standalone mobile toilets, and you don't have the real connection into the system. So what we want to do is something which is desirable for users, self-cleaning. So we don't want to use quite a lot of water, because at the moment, if you think about that, if I remember correctly, the figure is like half a kilogram of excreta that we produce, an adult produced in many societies, and then we use for each flush like 5 liters of water, and we use all of that thing and we transport it miles and miles, and then we treat using lots of energy and lots of space. So apparently common sense tells you that maybe it's not that smart to transport the whole thing and then you treat it in a very resource intensive way. So we want to make it smart. The challenge is to make it easy to maintain. So we are experimenting with some sort of nano coating, which basically will reduce the stickiness of material with that. Cultural acceptability. The world can be divided into people who sit and people who squat, people who wash and people who wipe, and there are associated difficulties with what you design. I've come across some people, using material and then trying to flush. And in one case, I saw people using, rocks in some hilly areas and trying to just flush it. And we were given this remit that it should be non-piped solution, and it has to have least dependency on energy sources. So before I go on that, so what we did was basically, the principle is very simple. There are some discussion about energy. There is a very good link between what we eat and what we excrete. So when you eat, you have some calorific value on food, 2,000 calories we eat. The thing is, what comes out, it still has some energy. And the figures people show using different diets is from 5 to 20 megajoules per dry mass. So the idea is that whether we can recover some of that energy from something which we try to just treat and not use. So that is one. The process that we are trying to use is called hydrothermal carbonization, which basically occurs naturally in converting material into like sludge into coal. But that happens over millions of years. So what we are trying to do is to achieve that in a very short period of time. And again, very simply, it is basically sort of pressure cooker, where basically you try to get the heat up to 200 degrees centigrade under 20 bar pressure, which basically kills almost any sort of known germs and things. and convert the material. And what comes out of it, basically three streams of things: some solid suspension, which we could extract and use for combustion, or we can use for soil improver. Liquid stream, we could extract some materials, nitrates, and gas, which we are thinking of looping back into the system. So very simple principle, linkages between the energy we take in and what we can recover, natural process, and then trying to use that as much as possible to run on its own. This is not a toilet, if you are visualizing where the toilet will go, but just a prototype to show our sort of concept. So if you think about, and if you want to visualize that you may have toilet somewhere there, and the waste is collected in this collector, very simply. Then we have a pump. Now, we are using pump at the moment, but that could be replaced by a solar-powered or some sort of, this is like, it uses, I think, 1.5, a lot less energy. So basically, the real thing which is happening is in this reactor, which again, to show the process, we have used the off-the-shelf components. This is basically a heat exchanger. It has 3 tubes inside, so material goes and passes through in 3 loops. And by the time it reached there, it has attained the temperature. Then basically material goes up, we sort of like reduce the pressure, and then the liquids and gas are collected. Basically, this prototype, basically could be used by 100 users. Now, because our phase 1, which was basically to prove our concept, was to do exactly that, because what is needed is ultimately to have household toilets which are using new principles. So that is the prototype which we took to Seattle. It doesn't look like toilet, but it shows the principle. Now, what I'm going to do before we go to question and answer thing is to recap that in May-June 2011, Gates Foundation invited 25 universities. They selected 8 universities, including our university, to come up with ideas, and then they gave this prize to 3 universities, Caltech, ourselves, and Toronto. Different technologies are being proposed. And recently we have got funding for the phase 2. And the challenge now is to develop this concept into technology readiness level 7, which basically is lab-tested system operating in operational environment. And we all are very excited to work towards that. We haven't finally resolved all the issues, but we think that we are on roads to some game-changing technologies. Thank you.
Thank you, Sohail. Now, who would like to ask a question on reinventing the humble loo? Yes. A fellow panellist, no less.
Hi, Gary Leet, University of Birmingham. How do you deal with changes in pH? I mean, say someone's sick in the toilet. Won't that change the bacteria flora?
You see, the thing is, at 140 degrees centigrades and above, we think all sorts of germs will be burned. So in terms of dealing with pH and things, of course, and of course the big issue is that if, let's say, all of a sudden you have a party in a house and there's lots of beer, and then all of a sudden your proportion of solid becomes like less than 8%, because the idea is that you need to have certain amount of solids to produce the energy. So if your proportion become less than 8%, almost liquid, then what do you do with that? These are the kinds of questions that we are sort of considering. But there are some large plants already operating, HTC, dealing with solid waste, particularly in Germany and Switzerland, where they are using 25 to 30% of proportion. But I think these are the kinds of things we'll be looking at. And especially the big challenge is how we can reduce the scale because we need a household toilet, but then in household we may not have the energy, the mass to generate the energy. So we may have to compromise a bit, and we may think about, like, rather than having just 20 users, we say, look, the minimum would be from 30 to 100 or above.
Yes, thank you to Gary for raising the Saturday night clubbing objection to that one. And anyone else got a question? I think you've wowed them all into silence with the reinvention. I mean, I just have a practical, which may have crossed people's minds, which is simply cost. I mean, you've alluded to it there, that you might have to sort of upscale to start with. I mean, even simpler new loo technologies. I got carried away with a Clerkenwell architect recently and almost agreed to having something where you washed your hands and then you used the wastewater for the toilet, which then turned out to cost £2,500. It's just... So, I mean, have you thought about how quickly you could get cost to a level that was scalable?
The target that's set is like 0.05 or 5 cents per user per day. Is the target that we are aiming, like $60 per family per month.
But my point is, if it's already so expensive, even to do something which sounds a bit simpler, which is to use wastewater, then
the thing is,
what's the timescale?
What maybe you're not adding in, that is not just that cost, but maybe £20,000 per family that we sort of incur in the UK for the pipes and everything. That's not really counted. So the thing is that our existing system is really very expensive. So I think you have a point, and it all depends on the standards as well. So I think our design team, along with the other grantees, will be looking into, because I think we do want to have like market segmentation. So we can think of like people who can spend lots of money on that, and also people who are poorest of the poor in developing countries to afford. But that's the target that we are aiming to.
Fascinating. Thank you very much. Thank you.